Adding up rectangles 3. Apply the midpoint rule with n equals 4 rectangles to estimate the area under the parabola f of x equals x squared plus 1 from 0 to 2, x between 0 and 2. Solution. Since n equals 4 rectangles, the width of every rectangle is delta x is 2 minus 0 over 4, that's a half. For the midpoint rule, we evaluate the function at the midpoint of every interval. That is the midpoint of 0 and 1/2, that's 1/4. The midpoint of 1/2 and 1, that's 3/4. The midpoint of 1 and 3/2 is 5/4. The midpoint of 3/2 and 2 is 7/4. Okay, let's calculate M4. M4 is f of 1/4 times 1/2 plus f of 3/4 times 1/2 plus f of 5/4 times 1/2 plus f of 7/4 times 1/2. Let's simplify this. M4 is equal to 1/2. Let's factor the 1/2 out. F of 1/4 is just plugging this back into the function, that's 1/4 squared plus 1. If we decimalize that, we'll get 1.0625 plus f of 3/4, that's calculated as 1.5625, and f of 5/4, that's calculated as 2.5625, and f of 7/4, that's going to be 4.0625. If we add up all of these, that's 1/2 of 9.25. That's 4.625. This is an estimate for the area under the curve using 4 rectangles and using the midpoint rule. Okay, let's summarize what we just did. Summary. Let's talk about how we got the midpoints of every interval and evaluated the function at the midpoints. Step 1. Delta x is 2 minus 0 over 4. That's 1 over 2. This is the width of every rectangle. Step 2 is average the endpoints of every interval to obtain the midpoints. So between 0 and 1/2, average that, we get 1/4. Average 1/2 and 1, that's 1/2 of 1/2 plus 1, that's 3/4. Average 1 and 3/2, you get 5/4. Average 3/2 and 2, that's 1/2 of 3/2 plus 2, that's 7/4. Step 3, evaluate the function x squared plus 1 at the midpoints. So find f of 1/4, that's 1/4 squared plus 1. F of 3/4, that's 3/4 squared plus 1. F of 5/4 is 5/4 squared plus 1. F of 7/4 is 7/4 squared plus 1. Step 4, add up these rectangles. F of 1/4 times 1/2 plus f of 3/4 times 1/2 plus f of 5/4 times 1/2 plus f of 7/4 times 1/2. Okay, thanks.